All right. I think we have done all these basic things of hydrostatics pressure, how pressure varies with depth, and how we can solve these vertical YouTube problems. I think we have done those. And lastly, we were discussing about the force by liquid on the side wall. Also, what is the point of application of the net force by balancing the torques? Have we done this particular question?
Yes, sir.
Yes, we have done that. So, in next question, yes, the liquid of density rho is kept inside a prism which has two triangular vertical side walls of length A. Find the force on the vertical wall and the slant walls. Alright, have you tried this question?
Yes, sir.
Yes. So, what's your answer? On the first triangular face, what's your answer? The force by the liquid? This triangular face, what is the force by the liquid? Can you tell me what's your answer?
So on the triangular face, I got 1 by 8 into rho g into a cube, and on the slant face, I got rho g a square L by 4.
Alright. So let us first try to understand what is the force on this triangular face. Okay. So force, we have discussed one formula for that. For the side wall, the horizontal force equation. Do you remember the equation for the horizontal force on the side wall? How do I find it? On any horizontal side wall, how do I find the net force, horizontal force on it?
By considering a small strip and then taking the
No,
force.
that is definitely a way, but we have derived another shortcut way to
Sir,
find the
pressure at
force.
the geometric center into area.
Yes, good. We will find the pressure at the geometric center and multiply it with area. We'll find the horizontal force. I think we have discussed this in our last class. If you remember, then what is this height at the geometric center? What is the depth of the geometric center inside the liquid? If this side length is A, if this side length is A, I think it
3 by
means A by
2 root 3 from the bottom.
from the bottom, not from the bottom. I have to find the depth, na? In order to find
Yes,
the pressure,
A by root 3.
A by root 3, yes. So I think the pressure at the center is rho g into A by root 3. Yes or no?
Yes, sir.
And with this, I will multiply the area of this triangle, which is root 3 by 4 A square. Isn't it? Have I got it correct? If you multiply it, I think root 3 will get cancelled out. So it is rho g A cube by 4. You should find this as your answer. Even if you have taken a strip, if you try to do it by integration, I think you will find the same answer. Have you done any mistake? Let us try to solve it by taking strips also. If I take a small strip here at a depth of y, what is the area of that small strip? I can find the force on that. What is the area of that small strip if I assume it to be at a depth y? And this thickness is dy. Then as this angle is 30 degree, So I think this will be y tan 30 degree, yes or no? This base,
The 2y tan 30.
yes, so total base is 2y tan 30 degree. So I think the pressure will be rho gy and the area will be 2 into y tan 30 degree into dy. Yes or no? Is it the df force? So I think it is the area, and then I can integrate it. It should be 2 rho gy by root 3. Tan 30 degrees root 3, right? It is 30 degree. So yes, and 2 rho g 1 by root 3 y square dy. I think it is inside it, right? From where to where I will vary my limit of y? Can you tell me?
0 to 2 by
3 by 2.
0 to root 3 a by 2. Yes. So
Yes, sir.
if you do it, check whether you are getting the same result or not.
Yes, sir.
Y cube means 3 root 3 a cube by 8 by 3. So root 3 gets cancelled, 3 gets cancelled, 2, 4. Yes, you are getting the same result. Right, alternatively. But yes, always this is the best way. If density is constant, you find the pressure at the geometric center. Right, forget about everything. You find the pressure at geometric center, just multiply it with area, you'll find your answer. For the horizontal force only, not the vertical force, horizontal component of the force. Is this part okay for all of you? Just check whether this force on triangular face is clear to all of us. Okay. Now what is the force on this slant rectangular face? There are two ways I can find this answer. Have anyone got your answer?
Yes, sir. Is it 3 by 8 rho g a square into L?
3 by 8 rho g square into L. Okay. How do I do it? There are two different ways, or actually three different ways. You can integrate and always you can find your answer.
Pressure or projection?
Yes.
For pressure into area projected part.
But
Yes,
that
sir.
is only the horizontal part. I am asking what is the net force on the vertical wall?
So after we find the horizontal part, then we can take it as a component of that
Yes, net
net
force.
force.
Yes.
And then we'll
That
get the
yes,
answer.
that is one way you can do it. So suppose this is the rectangular side face, right? I should slant it at an angle of 30 degree. Yes, 30 degree with the vertical line. Yes. Right. So if you check that it is inclined at angle 30 degree from the vertical line, right? So if you take a projection of it, if you take a projection of this on this vertical plane, then the projection should look like this rectangle. Yes or no? In this case, what is the horizontal component that I can calculate? Can you tell me what is the horizontal component of that force?
3 by 8 rho g a square into L I got.
What will be that vertical height now? If this height is A, it is root 3a by 2 or not?
Yes, sir. Yes, sir.
And this is L given. So the force on this, it will be just pressure at this center, which is rho g into root 3a by 4 into area, which is root 3a by 2 into L. Yes or no?
Yes, sir.
So from there you will find that divided by 8 and a square.
Rho g a square L.
3 rho g a square by 8L. Yes or no?
Yes, sir.
Yes.
Yes, sir.
Now, if I say that the horizontal component of F is this one, so again you can just see a side projection that if this is the uh, plate, and the net force will always be perpendicular to that, right? The net force is perpendicular to that. Force by liquid is perpendicular to that, and this angle must be 30 degree. Then if this is F, this
So
angle
we
is,
don't need to calculate the vertical force. So because it will be the tan theta. Means
I am not
if we want,
calculating the vertical force. I am calculating that F cos 30 degrees is equal to Fh or not.
yes, sir, yes, sir, that method only.
So I can say F cos 30 degree is equal to Fh. So from there we can find F is equal to cos 30 degrees root 3 by 2. So I think it is root 3 rho g a square L divided by 4. Have you got this as your answer? Just check. Yes, have you got this?
Yes, sir.
Okay, good. So that is one of the way we can calculate the force. Now there is another way that we can first calculate the vertical force, then we can calculate the net force. Can you tell me how do we calculate the vertical force? How do we calculate the vertical force? Look, there is one way we can calculate vertical force. An interesting way, you try to understand this. Okay, I'll erase this board now. Alternate way, to find FV. Look, don't be confused with any of the methods. You can use whatever method you like, right? But if someone asks directly to calculate FV, then I think this method is suitable in that case. Look, can I say the free body diagram of this part of the fluid? I will draw the free body diagram of this part of the fluid. Which part? The part inside the prism, right? So the this thing I am drawing is not the prism but the fluid only the fluid section on the prism. Can you tell me what are the different forces? I'm drawing the cross section only, right? Let me draw the cross sectional view, then it will be more clear. Only the cross section view. So this is the cross section view of the fluid that is kept inside the prism. Now tell me one by one, what is the force, what are the different forces acting on this water?
So normals from the three parallelogram sides.
All right. So I will take normal from this ground. Ground means the container base. Normal from this container side face, normal from this container side face.
And the weight of the
And the
liquid.
weight, yes, and the weight. This is N, this is R, this is F, and this is F. And this is W, right? So this is the free body diagram of the fluid, of liquid. Now here you cannot find the horizontal component of the forces because the horizontal components will cancel out. Yes or no?
Yes, sir.
These are the same value of same force horizontal component that we have calculated earlier. But these are the vertical component. Yes or no? On the fluid it is downward, on the container it was upward. So if I write down a force equation, what should I write? Can I write Fv to Fv rather?
FB plus W equals to N.
Yeah, 2FV plus W equals to N. For the
Now what is the
vertical.
value of N? Can you tell me what is the value of N?
So rho G into root 3 by 2 into area of the.
Yes, good.
Yes, sir. Rho G into root 3.
N is the what is the force liquid is offering to the base? Base is offering the same force. What is the force on the base? That is very easy to calculate. It is rho g into h divided by the area of the base, which is a into L uh, area, and rho g root 3 a by 2 multiplied by a into L. Have you got it, everyone?
Yes, sir.
Pressure at the bottom is rho g h. H means root 3 a by 2 multiplied by the base area, which is a into L. Okay. So I have got it rho g a square root 3 by 2 into L. What is the weight of the liquid? Can I find the volume of the prism?
Sir, rho into root 3 by 4 a square into L into G.
Good. The area of the triangular plate is root 3 by 4 a square. Multiply it with L. It is volume into G. So from this equation, now can I find what is Fv? Just try to calculate and check whether we have got the same value of Fv or not. Fv is equal to n minus w by 2. So n minus w is, if I take root 3 rho g a square L, I think it will be divided by 4 only. Root 3 rho g a square L by 2, root 3
Yes, sir.
rho g a square L by 4. So the value of Fv is equal to root 3 rho g a square L by 8. Now what is Fv? If this is F,
Sine F sine 30.
then this angle is 30 degree. Which angle is 30 degree? Yes, this angle is 30 degree. So
Between F and
F sine 30 degree, Fv is equal to F sine 30 degree. So what is the value of F? Root 3 rho g a square L by 4. Have we got earlier the same answer?
Yes, sir.
Yes. So look, that is a way we can calculate Fv directly. We also know how to calculate Fh directly, and you can anything, if you can calculate Fv or Fh, you can calculate what is the net force F from there also. All right, have you got it, everyone? Just check. Is this okay for everyone? No doubt in this particular process?
No, sir.
Okay. In next question, it's given that a submarine window of radius r and depth h below water surface. Find the force by the liquid on the surface of the window. I think that is easy question. We can now easily find what is the force. The window is vertical, so I will only find the horizontal force. And what is the horizontal force? Tell me what equation, what will write here about the horizontal force?
The H plus R
Rho G
into rho G into pi R square.
Good.
by 2.
Rho g into h plus r. It is the pressure multiplied by pi r square. It is the answer of
Yes,
this
sir.
question. Yes. If you want to do it by calculation, you will find a lengthy solution for it. But we can easily use the same concept here. Yes.
The calculation, it was
Easy
it's
calculation.
very long calculation.
Yes. A very lengthy calculation it will be because it is a circular plate. But again, you can do it by the same method. Okay. I think we have understood how to calculate FH. FV we have not calculated much, but we can do few calculations. Yes. Now this question says a liquid of density rho is kept inside a container. Find the horizontal and vertical force on the slant face. This is the slant face as shown in the figure. Can you calculate? Have I given it as your homework?
Yes, sir.
Yes. Okay. So what's the answer of this question? Have you found any answer of this question? What is the value of horizontal and vertical force on the slant face?
I couldn't find the vertical force.
Acha. If you got the horizontal force, I think vertical force you could have also found. What is the horizontal force? Okay, let me do it separately, right? Horizontal and vertical separately. So if this is the suppose suppose the face is like this. So in order to calculate the horizontal force, I will take its projection along this vertical line, and the projection is look like something this. A rectangular projection looks like this. What is the length of this rectangular projection? It remains the same as A. And what is the height of this projection? Is it C sine theta or not? Is
Yes,
that
sir.
height C sine theta? So what is the horizontal component of that force that I can easily calculate?
So mu G into H plus C sine theta by 2
into
into
H
A
plus
sin
theta
theta.
by 2.
Yes. Rho g into C sine theta by 2 into C sine theta into A.
So plus H, I think.
So plus H.
Yes.
Yes, sir. C
Theta
sine
by
theta
2.
by 2 plus H.
C sine theta plus H.
So C
No,
sin plus
theta
2H. So plus
no,
2H.
that 2 will be below the
Yes.
sine theta only, not the. Yes, sir.
Okay, let me write it afresh. It is rho g into H plus C by 2 sine theta. It is the pressure and whole multiplied by the area, which is AC sine theta. Yes or no?
Yes, sir.
It is the horizontal component. Can you try to calculate the vertical component by the method that I have just discussed? Try to find the vertical component by the method we have just discussed. Then I will solve it. Try to do it by yourself first. What is the vertical component?
Sir, but in this case, shouldn't it be a lengthy?
No. In this case, it is also simple.
Sir,
Hmm?
sir, in the previous case, when we took the weight, means it was the weight of the total that liquid column which was there,
Yes.
and it was passing through the center of mass.
Hmm.
Sir, but in this case, like, how should we
In
consider
this case,
that
I will
element?
only take the liquid inside this wedge.
Yes, sir.
I will only draw the free body diagram of the liquid that lies inside the wedge.
Yes, sir.
This liquid. Only draw the free body diagram of this liquid. Rest of the part, I won't bother. Have we got the free body diagram correct? Just check. So the equation of this free body diagram would be N is equal to W plus Fv. So what is the value of Fv? What is the value of N here? Can you tell me what is the value of N?
The rho g h plus c cos theta
Yes.
into
Sir, rho g h.
AC cos theta.
C cos theta or sin theta? Rho
Yes,
g,
sir. Sin theta.
So see sin
rho
theta.
g h plus C sin
Into
theta
AC cos theta.
Yes, sir.
multiplied by AC sin theta, AC cos theta.
AC cos theta.
Yes, sir.
Good. And what is the weight?
So weight will be c square sin theta cos theta into a into rho into g.
Hmm. Half into what is the area of this triangular section? Half
Sir,
into C
half
square
into c square sin theta cos theta.
sin theta cos theta.
Yes, sir.
Multiply it with the area area into length is volume and into
Yes,
rho
sir.
g.
Rho g. Yes, sir. This one.
So I think we have calculated Fv from here only. So here it is, look, rho g h AC cos theta plus rho g AC square sin theta cos theta. Here rho g AC square sin theta cos theta by 2. Right? So if I subtract W from N, so I think the thing I will get is rho g h plus half of this rho g AC square by 2 sin theta cos theta.
Yes, sir. It is matching only because fh cot theta equals to fv. It is coming.
What cot theta?
Fh cot theta equals to fv.
Yes. So now you can just simplify. It is rho g into h plus AC square by 2 sin theta cos theta.
Sir?
Yes.
Sir, there will be one cos theta with the rho g h.
One AC cos theta. Rho g
Rho g h into
cos
AC cos theta. AC cos theta is there. Yes, yes. I missed that part. Rho g h into AC cos theta. Right? So it is rho g into AC multiplied by h cos theta plus c by 2 sin theta cos theta. Yes or no?
Sir, here we won't take the forces due to the upward face, means the face which has h height and a as base length, and the face which has b height and a as base.
I am only taking the free body diagram of this part of the liquid. Is this part of the liquid in any contact with this face or this face?
Oh, sir, we're taking the FBD of liquid. Okay, sir.
I am only taking FBD of this part of the liquid, right? FBD of the liquid.
Okay, sir.
I'm sure that if you want to calculate by the component method, you will find the same value of FV.
Sir,
Yes, Bolo.
sir, we can all, if we take the FBD of the container, then
Yes.
in that case the force exerted by the topmost part will be 0.
By the topmost part, yes, because topmost part there is no. I'm only talking about the gauge pressure or force by liquid. The topmost part,
Yes, sir.
there is no other liquid above it.
Okay, sir.
Okay. So I think we have understood how to calculate the vertical force as well as the horizontal force on any side wall. Any doubt you can ask me, or else we'll progress. Have I given this question as your homework?
No, sir.
No. Alright. Try to find it. A liquid of density rho is kept inside a container. Find the horizontal and vertical force by the liquid on the curved surface. Only the curved surface at the bottom you need to calculate it. Okay. Let us try to find the horizontal force first. Suppose it is the cross section of the quarter circle. So if I get a projection on this, of this, will I get the projection again a rectangular face?
Yes, sir.
Yes, sir.
Right? And this rectangle will have this height R, this side A. So the pressure at this point is rho g R by 2 plus H.
Sir,
Yes.
sir, is the answer for the. Oh, wait. Is the answer for the vertical force rho g AR into H plus pi R by 4?
Rho g AR into H plus
Pi R by 4.
yes, I think that is the answer.
Yes, sir, that is the answer.
Yes. So the FH, the horizontal component of the force, is something like this. we have calculated rho g AR into H plus R by 2. Is there any doubt in this horizontal calculation?
Sir, is the vertical force rho g AR into 1 plus pi r by 4?
Rho g AR, no, there will be a term of H also.
Yes, sir. Rho g AR into H plus pi r by 4. It is coming.
Yes, sir, H. H
How
plus
do I
pi r
find,
by
yes, how do I find the vertical force? Tell me.
So we can take the part of the water on the circular part and above that.
Yes. If I draw the free body diagram of this entire part of the liquid that are above this part, circular part and this one, let me draw it the cross section view only. If I draw the cross section view of this liquid, can you see that cross section view of the liquid? What are the different forces acting on this liquid? If you see that forces acting on the liquid are, there is a net force by the liquid, by the container on it. This part of the liquid is exerting a sideways normal. This part of the liquid is, this part of the container is exerting a sideways normal. Top face is not giving any force because it is open, and there is a weight downward. You can see very easily that whatever may be this forces F1, F2, if I take the component of this force, one is Fh that I have calculated already, one is Fv that I need to calculate, and that is W. Horizontal forces are cancelling each other as well as the vertical. I am not bothering about the horizontal forces. But what is the vertical force? Is it only the weight of the liquid that is above it?
Yes, sir.
Yes. Because the vertical component is only balancing this weight. There is no normal reaction. There, this force is, yes, this force is only provided by this container wall, right? And liquid
Yes,
is
sir.
also providing the same force to the container wall. So this force is also the answer of Fv that we have to calculate. And what is the weight of this entire liquid that is only above this surface? If you see this front surface area, it is pi r square by 4 plus RH. If I multiply it with A, can I get the volume? Yes or no? Pi r square by 4 plus RH, pi r square by 4 plus RH. If I multiply it with A, I will get the volume. Multiply it with rho g. This is the weight as well as the answer of this second question?
Yes, sir. This is only coming.
So it is rho g A r, you can take r outside, and H plus pi r by 4. So
Yes,
that
sir.
is the answer to the second question. Have you done it in any other method?
No, sir. This method only.
Yes. You can draw the free body of the fluid in order to calculate the vertical force always.
Sir,
Bolo?
sir, can we do this by the component method?
Here can you use the component method?
No fixed theta. It is only fixed to means
Actually,
a
we
plane,
do not know
fixed
the
plane.
value of theta here. That is the problem. If you look, to the cross section view of this curved section, all the forces will definitely pass through the center. Yes or no? All the forces will definitely pass through the center. That is correct. Because liquid is exerting force normally, all the forces will pass through the center. But the problem is the magnitude of all these forces are not the same. Yes or no?
Yes, sir.
As you are going down, the magnitude of the force is going increasing. So you cannot say that the net force is passing through. The net force will definitely pass through this center, but the net force you cannot say will divide this angle. Net force is not passing through 45 degree. So if I do not know that angle, then it is difficult to find. Because you do not know the angle, you do not know the net force, as well as you do not know the vertical force. So it is no way that you can calculate FV. Have you got it? What I am trying to say?
Yes, sir.
This
In this
forces are,
question, we can apply only this method or the integration method.
yes, integration you can do, but again integration will be lengthy process. But this process
Yes.
always you can apply. Right. So the net force will act somewhere, but this angle theta is unknown. All right. I think we have understood this method. Only thing we have, I'm trying to make you comfortable with the calculation of FV and FH, right? Because later also questions can be easily solved if you can find this FV and FH. Definitely these are not a mains type or mains level question, but in advanced level you can expect anytime this type of questions. A log gate is made of one semicircular cylinder. This is the semicircular cylinder, cylindrical part rigidly attached with a vertical wall. This system can rotate about this axis, passing through the center of the cylinder. Find the maximum height h so that the gate can be opened. Find the maximum height so that the gate can be opened. Can you understand the situation? This is floor, right? Suppose this is a ground floor. Water is kept above it with the help of this lock gate. Above a certain height or below a certain height, if you keep water, then this lock gate will rotate. In which direction the lock gate will rotate so that the gate will open? Clockwise or anti-clockwise?
Clockwise. Clockwise.
Huh?
Sir, clockwise.
If it rotates clockwise, will that water come out?
Uh,
That you need to understand. Simple one. If you draw the situation in clockwise and anti-clockwise direction, suppose this is the actual position. If you rotate it in clockwise direction, the position will be like this.
So that cylinder is only means half cylinder is only tilting.
Yes, this entire part is tilting like this.
No, then it will not be clockwise.
So will water get out of this bus?
Yes, sir.
No.
No,
This
sir.
water will not get out of this construction.
Anti-clockwise.
But if it rotates anti-clockwise, then you can see that this part is fixed. That cannot move. So now the water will come out from here.
So that method can also be used. The clockwise means First, we will keep it stationary for some time in the tilting position and then fully rotate in the clockwise direction such that the stored water between the hemisphere and the wall passes out in the right direction.
How? Means you are going to make this construction like this, absolutely inverted.
No, sir.
Sir, he is talking about a discrete process. Once we fill the part submerged in water and then we completely rotate it, the water falls away and then again back to normal.
No, no.
Yes,
From
sir.
this
Then the
particular
water falls.
position, I think it is only this situation that is possible.
But for that we will get not get the maximum height, we will get a minimum height.
Yes, I think we will get a minimum height. We will get a minimum height. Okay, so in order to open that door, open the gate, I have to check about the torque about this axis. Yes or no?
Yes.
So, in order to open the gate,
Sir, about which axis?
axis through the center, this red color, this is an axis through the center. It is given,
Yes.
it can rotate about that axis. In order to open the gate, this entire construction, it should rotate anti-clockwise. Yes.
If it is rotating anti-clockwise, then we should get a maximum height.
Yes, sir. Rotating anti-clockwise, then we should get the maximum height.
Okay, all right.
If it
We'll
is
check. We'll check it. No
clockwise,
problem.
we will get minimum height.
Sir, is the radius of the hemisphere given?
Yes, yes, definitely. This radius should be given. This radius is R.
So that means the torque produced by the vertical force means its weight should be greater than the torque produced by the
Horizontal force, yes.
horizontal force.
Yes, yes. So this is the base and this is the vertical height. If I talk about the forces on the base, the force is everywhere same. So I can pass the force through the center of geometric center of this face. And where should I pass the force in this case of side face?
Sir, at h by 3 from the bottom.
Yes, at h by 3 from the bottom. As I mentioned in last class, that the pressure diagram forms a triangle. So at the center of the triangle means from the base it is h by 3. So this is h by 3 from the base and this is r by 2 from this axis. This is the vertical force and it is the horizontal force. So in order to open it, the torque of Fv must be greater than, in order to open it, torque of Fv must be greater than torque of Fh. Yes or no? What is the Fv?
So it is pressure plus weight.
Pressure plus weight means?
I mean the pressure due to the liquid plus the weight of it.
Pressure due to the liquid only.
Yes, why weight of the liquid? Weight of the liquid is pressure multiplied by area. You will find the same answer.
Okay, yes.
Fv is equal to, suppose liquid is kept at a height h. So Fv is equal to the weight of the liquid, which is rho g into the entire area multiplied by h? Yes or no? Area is, you can say, area I can take this area to be R into L. Yes or no? I'm talking about this area, this surface area. What is the surface area of this base?
Where L is the length of
L
the
is the length of
cylinder.
this section. R into L. Are you getting what I'm doing here? If you have any doubt, you ask me. F V is equal to rho G, only the weight of the liquid above. And what is FH?
Sir, H also will be there.
So into H.
Into H,
In the
yes.
previous
H.
part.
Yes, the volume I have to take, it is RL into H. And what is FH? FH is equal to rho G into H by 2 multiplied by H into L. Yes or no? Is it FH?
Yes.
Multiplied by
Yes.
H by 3. So I think we have got our equation where rho G R square is there one side. 2 gets cancelled out. Rho G if I cancel, so LH also gets cancelled out. LH gets cancelled out. So I can say R square is greater than rho G LH gets cancelled out. H square by 3. So I think H square should be less than 3R square. So H is less than root 3R. That should be maximum height, right? If H is less than root 3R, then only it can be opened. And if you fill it up greater than root 3R, then it will not be opened. If the long cylinder is in equilibrium in the given diagram, what is the ratio of rho 1 and rho 2? This long cylinder has liquid of density rho 1 in its one side and density rho 2 in its other side up to a height that are given in your diagram. It is in horizontal equilibrium as well as vertical equilibrium. Vertical equilibrium, it is balanced by weight and everything, normal force. You don't have to measure the vertical forces, only the horizontal forces you have to check.
Sir,
Yes?
sir, is this geometric center same as the center of gravity of the body?
If it is symmetric body, yes, always.
Okay, sir.
What is the answer of this question? Rho 1 and rho 1 by rho 2? Yes?
Sir, calculating.
Yes, calculate. What is the answer of this?
Sir, is it 1 by 6?
1 by 6.
So 1 by 36.
Yes, sir, 1 by 36.
I have to check 1 second.
I am also getting 1 by 6.
One by 6.
Sir, I am getting 1 by 9.
4.
Sir, I am getting 1 by 9.
So 1 by 36.
How you are solving this question?
Sir, I am also getting 1 by 36.
Sir, I took the projections of the surfaces.
Yes,
Yes, sir.
the projection of the surfaces always will be a rectangular projection.
Yes, sir.
If this inside length is L, then for this part, this height is 3r by 2.
Yes, sir, it will be 1 by 36. I took it R by 2.
3r by 2. So what is the force in this case? The force will be rho g 3r by 4 into 3r L by 2. Yes or no? So it is 9
Yes,
by
sir.
8 into rho g r square L.
Yes, sir, 1 by 36 it is coming. Yes, sir, 1 by 36.
Sir, rho 1 GRLs.
Rho 1, yes, it is rho 1. And for this this smaller section, the right side, the force by the liquid is in this direction. This is r by 4 and this is L. So it is rho 2 gr by 8 multiplied with lr by 4. Right? So that force is equal to rho 2. It is 1 by 32 into rho 2g r square L. Now these two forces must balance each other. F1 and F2.
Yes, sir.
Right? Because in horizontal direction, no other force is there. F1 equal to F2. So
Sir,
that
for
if,
equilibrium, we are only considering translational equilibrium and no rotational equilibrium.
It is not coming in rotational equilibrium.
rotational, it is always in equilibrium because all the forces will always pass through the center. So torque is not there. Yes or no?
Sir, in the previous few parts, we learned that when we are applying torque, we take the height approximate, means we take the average pressure to be at height h by 3.
Yes, yes.
Sir,
But
then
here if you take, then we are not getting equilibrium.
Sir, because sir, we have to consider the vertical also, and when we take the vertical and take them as a resultant, then at each point they meet at the center, means they pass through the center as normal. So they will all pass through the center and no torque will
Actually,
get.
all the forces are passing through the center here. In pressure diagram, you cannot find the direction of force. In pressure diagram, you can only say that the average pressure is lying at that point. But here, you cannot find the direction of the forces, right? The forces direction will always pass through the center. Every small cross section you take, the force will always pass through the center. So no question of torque is there.
okay, sir.
Yes, so I think rho 1 by rho 2 is equal to 1 by 36. That is the answer of this question.
Yes, sir.
Sir,
हाँ बोलो.
sir, what is the significance of a long cylinder?
Long cylinder means it is coming out of the plane or going into the plane very long, so that these liquids do not mix up, right? Otherwise, there on the other side of this back side or front side, there will also be a liquid.
Yes, sir.
So that is why this is a long cylinder. a sphere of radius r is completely immersed in a liquid of density rho such that the top of the sphere is at a depth h from the liquid surface. Find the upthrust by the liquid on the lower hemisphere and downthrust by the liquid on the upper hemisphere. Have you got the question? Question is this one. A sphere is kept inside a liquid like this, where this top surface is at a depth h, topmost point. So this is the upper hemisphere part and lower hemisphere part. You need to find the force by the liquid on the upper hemisphere and on the lower hemisphere.
Sir, is the sphere at equilibrium?
It doesn't matter. At some instant, suppose the sphere is here. So the force won't change even if it is in equilibrium, non-equilibrium. I'm not asking it about the net force on it. Only what is the force by the liquid.
Sir,
Yes?
see, is the upthrust rho g h plus r by 2 into pi r square by 2?
So I'm getting rho g into h plus 3r by 2 into pi r square by 2.
Okay, let us calculate the upthrust force. Okay, upthrust force. If you
Yes,
draw,
sir. Rho g h plus 3r by 2 into pi r square by 2.
So this is the upthrust and the rho g into h plus r by 2 into pi r square by 2 is the down thrust.
okay. So can I draw the free body diagram of this liquid? It is the fluid. If you draw the free body diagram of the liquid, tell me what are the forces acting on it? What are the forces I can show on the liquid? There is a normal reaction from the lower part of the liquid. Have you got what liquid portion I have drawn here? If you draw a cylinder and cut up this sphere hemisphere from there, then this is the left out water portion. Just below that lower hemisphere I have drawn that liquid. So it is the normal reaction. Any other forces there? Weight is acting, right? Its weight is also acting downward of the liquid, right? And the sphere is providing a downward force. Can I say these are the only forces on it? Horizontal forces don't matter. So downward force is this, weight is there and normal is there. Can I draw the free body diagram of this part liquid? Yes or no?
Yes, sir.
So it's very easy to calculate Fv from there. If I say Fv plus W is equal to N. And what is N? Can you tell me what is the normal reaction? At this base, what is normal reaction?
So 4r square into rho g into 2r plus h.
Yes, sir.
4r pi r square, no? Area is
Yes,
pi
sir.
r square.
Rho g into h plus 2r.
Pi r square into area. It is pi r square is the area and rho g h. What is the height? H plus 2r or not?
H plus 2r.
What is the weight of this part of the liquid? This part of the liquid, is it the volume of this cylinder minus volume of the hemisphere? What is volume of the cylinder? Pi r cube or not? Pi r, this height is also r. This is also r. So volume of the cylinder is pi r cube. And what is volume of this hemisphere?
Volume of the hemisphere is pi.
2/3 pi r.
Volume of the hemisphere is 2/3 pi r.
No, okay. So the hemisphere is 2/3 pi r cube.
Into rho g. So I can find what is Fb from here only. It is 1/3 pi r cube rho g. 1/3 pi r cube rho g. So Fb is equal to pi r square rho g, pi r square rho g h plus 2 pi r cube minus 1/3 pi r cube. So 2 minus 1 by 3 is 5 by 3 rho g pi r cube. I think your answer should be pi r square rho g into h plus 5r by 3. Have you got this as your answer? Check if the calculations are okay or not.
So won't the weight be 4 r cube minus 2 by 3 pi into r cube into rho g?
Weight 4r cube.
So, yes, sir.
Why I have taken the volume of this cylinder minus volume of the hemisphere. So what is volume of the cylinder? Is it pi r square into h?
Yes, sir. Pi r square into 2r.
It's not 2r. I have taken.
Yeah.
Have you understood what portion of the liquid I have taken? It is only the liquid below this lower hemisphere. Liquid lying below this lower hemisphere. So this height will be this one just. If you want to see it
Yes,
here.
sir. Height is r, but the radius I'm talking about.
How the radius is 2r. Radius of the cylinder is also r.
Yes, sir, understood.
Okay, sir. Understood.
Similarly, can we find what is the force on this upper hemisphere? Force on the upper hemisphere is easy. Can I only take the weight above it, weight of the liquid above it? If you draw the free body diagram of this liquid, this force is F and this is the weight. Is there any other force in vertical direction? Yes or no? For this part of the liquid, it is a down thrust
No other person.
and it is the up thrust. So F is equal to F down is equal to weight. What is weight? Weight of this part is how much? There is one full cylinder and one this part, right? One full cylinder means pi r square h plus it is 1/3 pi r cube. Yes or no? Into rho g. So that should be your answer for down thrust. Pi r square rho g into h plus 1 by 3r. That is the down thrust and that is the up thrust.
Sir,
Yes?
sir, Sir, how did we calculate the n when there is a ball in between?
Where?
Sir, in case of the upthrust.
Acha, this n normal reaction.
Yes,
Whatever
sir.
it may be, if there is a ball, everywhere on this liquid surface the pressure remains the same, yes or no? So you think
Yes,
about
sir.
this pressure. What is this pressure? It will be directly the pressure here also. Yes or no?
Sir, is the density of the ball same as that of the liquid?
No, I'm not talking about density of the ball. Why it will be same? What is the pressure? I'm drawing free body diagram of the liquid. So if suppose there were a base here, the container is ended. The base of the container is only here. Then what is the pressure at the container base by the liquid? Would you consider the density of the ball, or you will only consider density of the liquid in order to find the pressure at this point?
Yes, sir, only liquid.
So it is rho g into h, what I have calculated here. But h is from the top, h plus 2r.
Okay, sir.
Alright, so we have done few questions on the forces by the liquid on side wall, right? Or on the base, whatever it may be. Any type of surface now you can handle to find out the forces. Is there any doubt regarding this particular solution? Alright. I'll leave this question for your homework. Okay, there is a thin cone inside which there is a liquid of density rho 2 and outside the density rho 1. So what is the rho 2 by rho 1 ratio so that it remains in equilibrium? Right, light cone means the mass of the cone is negligible. Okay. So till now we were finding all these concepts, pressures, forces, everything in a liquid which is kept in a container which is at rest. But now we will talk about the liquid which is kept in an accelerated container. As you can see that if this is a liquid kept in this container, and if I move this container in horizontal direction with some acceleration, then this container will, the free surface of the container will not be horizontal. Now the free surface of the container will make certain angle with the horizontal line, right? So we are going to find this angle, and also we will try to find what is the variation of pressure. What is the variation of pressure at different points in the liquid? Okay. So let us try to first find if it is kept in a liquid in a container which has an upward acceleration AV. If AH is equal to 0, if AH is equal to 0, suppose for the time being, if AH is equal to 0, then what is dP by dy? Can you tell me what is dP by dy? If this is my y-axis, suppose this is my y-axis, this is my x-axis.
Minus rho g into AV plus G.
Minus rho into G effective.
G effective.
Minus rho into G effective. The proof is very similar where we have done the proof of minus rho into G. Instead of G, now you can see a G effective, right? If it is moving with AV, then with respect to container, when I will draw the free body diagram with respect to container, if I take a small cube or cuboid, what are the different forces acting on it? Can you tell me? The pressure force from top and pressure force from the bottom. And there is a weight. Anything else? I will draw.
No, sir.
Pressure force from the top is P of y plus delta y into area. From the bottom is P of y into area. Do you remember that? If I assume this height is at y.
So we have to take one pseudo force.
Yes, we have to take one pseudo force. The pseudo force is also coming down, which is F pseudo. Right? Now if you write down the equation, you will find P of y plus delta y into A minus P of y into A plus W plus F pseudo equal to 0. So P of y plus delta y minus P of y into A is equal to minus of, what is weight? Weight is rho g into A into delta y. And what is pseudo force? Pseudo force is mass, which is density into area into delta y into AV. Yes or no? So if you simplify it, you will find it is rho g plus AV into A delta y. Yes or no? A gets cancelled out, and now as we have taken the limit P of y plus delta y minus P of y divided by delta y, limit delta y tends to 0, I can take this as equal to minus rho into G effective. What is G effective here? dP by dy equal to minus rho G effective. Here in this case, G effective is G plus AV. If it is going downward, what will be G effective?
G minus AV.
minus AV. Right? Here, G effective is G plus AV. Right? So if it is moving upward with some acceleration AV, then the pressure variation is simple, minus rho G effective. G effective means G plus AV or G minus AV. Right? If there is no H, then in X direction there is no variation of the pressure. Right? dP by dx equal to 0. Yes or no? Along x direction there is no variation of pressure if it is only moving with AH. Only moving with AV. But now the question is, if it moves with AH, will there be a variation of pressure with X? Yes or no?
Yes, sir.
Yes. Can you just try to find what is the pressure variation with X if it moves with AH? Using the similar type of calculations, you just try to do it. I will definitely do it after some time. The second case, if AV equal to 0, let us assume AV equal to 0. AH is there. Okay. So if you take a similar type of cube, a similar cuboid that we have taken in last calculation, But here, with respect to container, everything I am drawing, right? With respect to container. With respect to container, what are the forces on this cube? I am not talking about the vertical because AV is 0, right? So I can say that in horizontal direction, this pressure will be P of x if I consider this surface to be at a distance x, and this distance is delta x into A, right? And this force, and from here the force is P of x plus delta x into A, and there will be a pseudo force also. If AH is in this direction, the pseudo force comes in this direction. So the equation that I will get is P of x plus delta x into A minus P of x into A plus F pseudo equal to 0. So P of x plus delta x minus P of x multiplied with A is equal to minus F pseudo. What is F pseudo here? Rho into A into delta x, volume multiplied by acceleration AH. Yes or no? So I can now take limit delta x tends to 0, P of x plus delta x minus P of x divided by delta x, A gets cancelled out, is equal to minus rho AH. So here I can say dP by dx equal to what? Minus rho AH.
Sir?
Bolo?
Sir, shouldn't we consider the change in height of the liquid column?
Change in height of the liquid column, that balanced with this horizontal, this vertical force. If there is a height change in height, that is why in the same horizontal level I have got two different pressures. You have already considered it here.
Okay, sir. Okay, sir.
Have you got it? If this is x, this is y, then I can say that the pressure here will decrease in the direction of h, acceleration, right? Pressure will decrease in the direction of acceleration, or pressure will increase in opposite direction to the acceleration. Right? You should remember it here that pressure decreases in the direction of acceleration. Right? dP by dx equal to minus rho AH. Okay. So here also we can find this angle theta from this calculation if you want. How do I calculate this angle theta now? If you see that during this dx change, calculation of theta, can I say that due to this change dx, suppose this was y,
Sir, we know dP by dx and we know dP by dy, so we could divide them to get the slope, divide dx.
dy by dx, yes, also you can say that. Yes. You can see that at this point the pressure is P of x, and this point the pressure is P of x plus delta x. So why the pressure is different? Because of the difference in height only? Yes or no?
Yes, sir.
So if I say that this is the dx, look, the pressure at one point you can calculate in different ways. I can say that the pressure difference from here to here is due to this horizontal acceleration. But you can also say that pressure difference is also due to this height. Both are the same, yes or no? Pressure difference at this point Px is more than P of x plus delta x. Why? Because the height above Px is more than the height above Px plus delta x. And what is the change difference in that height? This dy, right? And this angle is theta. So what I can say that here this the difference in this pressure is due to the difference in this height dy, right? So P of x minus P of x plus delta x, it is because of the difference of height dy, which is rho g into dy, right? And what is P of x minus P of x plus delta x? P of x minus, it is rho into ah into delta x. So rho into ah into delta x is equal to rho g into delta y, right? You can say that it is delta y. So it is very easy to calculate that delta y by delta x is equal to tan theta. Delta y by delta x equal to tan theta. And what is the value of tan theta then? It is a by g. Horizontal acceleration divided by g. It is the value of the tan theta. Have you got it?
Sir, if it were accelerated in both directions, it would have been imaged by
G effective. Yes. Yes. Now if it has AH and AV both, then you can say that tan theta, if AH, AV both are there, then tan theta will be AH divided by G effective, right? So that is a calculation of theta. Now theta can be calculated in another way also by drawing the free body diagram of any fluid particle, right? Alternatively, if you see a fluid particle on this surface, suppose this is a fluid particle of mass dm. With respect to container, if I want to calculate the forces on it, can you tell me what are the forces on this fluid particle? One weight is there, which is dm into g. This fluid surface will exert a normal reaction to it. Will there be a pseudo force on it, which is dm into ah? Yes or no? This angle is theta. With respect to container, it must be at rest, this fluid particle. It does not flow. As I have mentioned earlier that shear force must be 0, otherwise the fluid will flow. So can I make the shear force 0? If I make the shear force 0, what equation I will write? Shear force is 0. Shear force means parallel to the surface. Can I say dm ah cos theta equal to dmg sin theta?
yes, sir.
Yes, sir.
Dm ah cos theta equal to dmg sin theta. So from there also easily you can calculate that tan theta is equal to a by g. Okay. So that is the full understanding of the liquid kept in accelerated container. Is there any doubt regarding this particular proof, this derivation? You can check what we have done. Alright. So it is very obvious that now if I ask you to find the pressure at this point, any arbitrary point, suppose I want to find the pressure at this point, right? The location of this point I will give. This is x, this is y, and this coordinate of this point is x comma y, right? Take atmospheric pressure to be P naught. So can you tell me what is the pressure at this point? Suppose this point is O, or the pressure of this point A. What is pressure of this point A? You can
So what is
assume,
that minimum height?
yes, this height you can assume to be h. This height is given, it is needed. And also this length you can take L.
Sir, is it P naught plus rho G into H minus Y
Mhm.
plus rho H into L minus X?
Is it rho g, or there are two both the accelerations are there, AH and AV?
Then it will be G plus AV.
Yes, good. Look, how do I calculate it? In order to move this point, I will first, in order to move this point A, I will first come down from this point, right? This point. So pressure at this point, I know it is P naught. If pressure at this point is P naught, can you tell me what is pressure at this point? This height is, this depth is H minus Y. So if I am coming down, the pressure at this point must be P naught plus rho G effective, which is G plus AV into H minus Y. Yes or no? Let us assume it to be P1. And from P1 to PA, I am moving away from opposite direction to the AH. So the pressure should increase. So what is pressure at this point? If I am moving now horizontally, the pressure gradient is rho into A. So if this length is L minus X, dP by dx is L minus X. So change in pressure is rho AH into L minus X. So this pressure will be P1 plus rho AH into L minus X. Have we got it? So the pressure at A will be the addition of P1 and this P naught plus rho into G plus AV into H minus Y plus rho AH into L minus X. Tell me if you have got it.
Yes, sir.
Okay. You could have also found the answer by directly find the height above the point A. Right? If you directly find the height above the point A by geometry, you will find the same result, I think. Okay. So, one second. Alright, so today I have to finish my class here.